Niels Bohr, a Danish scientist, was the first to shed some light on the arrangement of electrons in atoms. He did this by studying spectra. A continuous spectrum is defined as a spectrum containing many colours or wavelengths with no gaps. You might be familiar with this type of spectra already. Example, rainbows. The spectrum goes from red to violet. Richard of York gave battle in vain is a useful memory aid to help remember the spectrum. White light, when shone through a prism, produces a continuous spectrum. White light is simply sunlight or light from a normal electric light bulb. Bohr put hydrogen gas into a discharge tube. Electricity caused the hydrogen gas in the discharge tube to produce its own light. The light then shone through a prism. Instead of getting a continuous spectrum, Bohr discovered a series of coloured lines. He called this an emission line spectrum. Bohr tested this out on a number of elements and found that each element produced a unique line emission spectra. A spectrometer is a device used to study spectra. Bohr believed that electrons orbit the nucleus along a fixed path called orbits, also known as energy levels. He stated that these electrons in an orbit have a fixed amount of energy, i.e., they are quantized. An energy level is defined as the fixed energy value that an electron in an atom may have. Energy levels are represented by the lowercase letter n. The first energy level equals n equals 1. The second energy level n equals 2, third energy level n equals 3, etc. The following video will help explain Bohr's theory. Electrons exist in their ground state, that is the lowest available energy level. We are looking at hydrogen, which has one electron. If the electron in hydrogen gains energy, such as heat, light, or electrical energy, it becomes excited and moves up in energy level. Excited electrons are unstable and so will fall back to their original energy level when possible. As the electron falls back to its original energy level, it will give off a photon of light. There is a formula we will use to show this. E2 minus E1 equals HF. Planck's constant is found in your log tables. It's just a formula you need to learn off, as I've never seen a calculation for this formula in exams. Finally, you need to be able to state which series corresponds to which energy levels. Electrons that fall back to the first energy level are part of the Lyman series. Electrons that fall back to the second energy level are part of the Balmer series. This series consists of visible light. Electrons that fall back to the third energy level are part of the Paschen series. Both the Lyman and Paschen series cannot be seen by the naked eye. Atomic absorption spectrometry. Scientists began to study spectra in more detail. They replicated Bohr's experiment, but changed one important factor. Instead of hydrogen emitting its own light, they shone white light through a sample of hydrogen gas into a prism. Note, it is important to state that the sample being used is in a gaseous state. The scientists saw a continuous spectrum with missing lines. They concluded atoms can also absorb light. The wavelengths of light absorbed by the sample correspond exactly to the wavelengths that would have been detected on an emission line spectrum. AAS is used to detect particles that make up gunpowder in forensics. It is also used to detect harmful metals in blood, and it can be used as quality control of water and food products. It is easier to do an AAS analysis than by the means of Bohr's method. The principle behind AAS is that atoms of an element in its ground state absorb light of a particular wavelength. The amount of light absorbed is directly proportional to the concentration of the element in the sample. Energy sublevels. Technology improved over time, and so did the study of spectra. Scientists studying the emission line spectra discovered that the single lines produced, i.e., energy levels, were actually made up of multiple lines extremely close together. They deduced that they couldn't be energy levels as they were too close together. Scientists called them sublevels. Scientists then realized that the number of sublevels corresponded with the main energy level. For instance, the n equals 1 energy level had one sublevel, whereas the n equals 3 energy level had three sublevels. A sublevel is defined as a subdivision of a main energy level and consists of one or more orbitals of the same energy. We will study sublevels in greater detail in the next chapter. I recommend that you re-watch this segment of the video after you've watched chapter 3, the periodic table on sublevels. Fast forward to 1924, where French scientist Louis de Broglie put forward his hypothesis that would first cause scientists to doubt Bohr's theory. He correctly hypothesized that electrons and atoms move in a wave motion. If this were true, then Bohr's theory of electrons moving in a precise path around the nucleus cannot give the full picture. De Broglie's idea led to German physicist Werner Heisenberg stating that it is impossible to measure at the same time both the velocity and the position of an electron in an atom. For your leaving certificate, you need to be aware of the limitations of Bohr's theory. Heisenberg's principle now means we must use the probability to determine the location of an electron in an atom. The more dense the dots are, the more likely the electron is to be found in that position. An orbital is defined as the region in space close to the nucleus in which there is a high probability of finding an electron. Schrodinger helped find out the probability of finding an electron in a sublevel of an atom. Schrodinger deduced that s orbitals are spherical in shape, and that they only differ in size depending on the main energy level. The s sublevel are not circular. It is important that you state they are 3D shaped, therefore spherical. The p sublevel contains three orbitals, which are all dumbbell shaped. They lie in the axis x, y, and z. Each orbital can hold a maximum of 2 electrons. You will study orbitals in greater detail in the next chapter.